Hello, welcome to this video tutorial all about solving equations. We'll mainly deal with basic equations today, which are along the lines of one-step and two-step linear equations, and then at the end we'll look at some trial and improvement stuff. How to solve an equation using the trial and improvement method. However, we'll get to that later. First of all, we'll look at one-step linear equations, which hopefully, as the name suggests, it can be completed in just one step. So, let's take a really simple example. X plus 3 equals 8. And the idea of any equation is to solve or to find out what the unknown quantity is. In this case, it being this x. So, how do we do that? Well, some of you may have already noticed that you could just say, well, what number must I add 3 to get 8? And the answer being 5. And that's fairly simple to do. However, some equations, in fact most equations, will not be that easy. You cannot kind of do it that way, especially if there's some decimal points involved, you know, like 3.12 and 8.45 or something like that. It makes it a lot harder. So how do we do it? Well, we're going to go to a graphical method, which is a balance scale. So this is like a scales that you'd use in the olden days or something like that to measure weights of things. So if we have, say, a bag of sugar on this side and we've got this tipping bit here, then the actual scales would tip down to the left. However, if we were to then put a bag of scales on the right, it would actually remain balanced. However, now if I put another bag on the left, then it would tip to the left. If I then put another bag on the right, then it would remain horizontal again. And what we can say is when the same on the left, when the amount on the left is the same on the right, it's equal or balanced. So it's almost like having an equal sign just here. That's a practical example of things that you may find in your kitchen or at home somewhere. Now we're going to look at equations. So this x plus 3 equals 8. Well, how do we do that? Well, this equals can be used here. And we're saying that x plus 3 is the same as 8. So if we were to put like a weight or a mass onto x plus 3, we're saying x bags of sugar plus 3 bags of sugar equals 8 bags of sugar. Then we know that it will be balanced. And the big question that you always need to ask yourself when solving equations is, what am I trying to achieve? And that is to get x on its own. Because if you think about it, if at the end we have x equals something, then we've found it. We must have found what x equals if we're saying that x equals. That's the nature of the solving equations. So at this point we can say, well, how do I get x on its own? Well, clearly I've got this plus 3 bit that I want to remove. How do I remove it? Well, I'll just do the opposite. I minus 3. But because I'm minus 3 on the left, I must minus 3 on the right, or take away 3. So we've got this bit here and this bit here that we're doing to both sides of the equation. And that's a really important point. If we do something to both sides of the equation, then it will always remain balanced, or it will always remain equal. But if I were to take 3 away from the left but never done it to the right, it wouldn't be equal anymore, and the scales would tip, and we'd actually be calculating from there onwards a wrong solution to the answer. In fact, it wouldn't even be a solution. Okay, so what are we going to do from here? Well, we go to the next stage, the next step, which is the line underneath the equation. So what's on the left-hand side now? Well, what's happened here? We tried to get x. Now remember, ask yourself that question, what am I trying to achieve? I'm trying to achieve x on its own. And by having x on its own, that means this plus 3 and this minus 3 kind of cancel out. So all I've got is x. And then the equal sign. And then on the right hand side I had 8, but then I had to take away 3 in order to balance it. So there we go, I have x equals 5, and that is our solution. So that's a one-step equation. Now what we're going to do is exactly the same again, but with a different question. So x take away 21 equals 83. And as you can tell, this one's not quite as easy to say, oh, what number must I take 21 away from to get 83? It can be done, slightly more harder, but the aim is really for this just to improve our technique in doing this. You don't have to draw your balance scales every time, but for this question I'm going to just to kind of keep it hopefully a bit more simple in explaining stuff. Remember, we've got this equal sign that goes in the middle, and we're saying that x take away 21 equals 83. X take away 21 equals 83. Ask yourself the question, what am I trying to achieve? I'm just going to put that second row here. What am I trying to achieve? Well, we're trying to achieve x on its own. How do we do that? Well, this minus 21 must be removed. How do we remove it? Opposite, plus 21. So do that to both sides, and you're onto a winner, because on the left hand side now we have just an x, which is what we were after. On the right hand side, 83 plus 21 makes 104. So x in this case equals 104, and that's the solution to our equation. We found out the value of x. It's really important to do the same to both sides. Hopefully that's kind of making a bit of sense, and you can just do some practice on that if you download the electronic book from the library. Okay, so from here, what we're going to look at is two-step equations, and again, self-explanatory. It requires two steps, whereas the last one only required us to say add the 21. This time we're going to have to do two steps. So, best way to do it is just jump into an example. So I've got 5x take away 12 equals 18, and I'm going to use the balance scales again for this, because it does make it a bit easier to visualize. However, you can kind of just visualize it by, you can just draw in a pencil if you wish to, and put the point where the equal sign is, because that's generally what it is. But anyway, what we've got on the left, 5x minus 12, then an equals, and that must equal 18. So how do we solve this particular equation? Well, we've got 5x, which is 5 times x. We've got 5 lots of x here, and then we're taking away 12 from that. So if we were to kind of look at the BIDMAS, brackets, indices, division, multiplication, distance, subtraction, when solving equations, when rearranging equations to solve what the value of the unknown, the x is, it's always a kind of a good rule of thumb to follow BIDMAS, but go backwards this time, because we're not substituting, we're solving an equation. We're not substituting numbers in for letters, we're trying to find out what the letter is. So if we kind of go backwards, and when you get to say subtraction, just ask yourself, have I got any subtractions here? Well, here the negative is minus 12, so why don't we get rid of that first? That's what this whole BIDMAS thing is for. The backwards BIDMAS anyway, for solving equations. So that's what we're going to do now. 5x take away 12. So this take away 12, what we're going to do is say, I'd like to remove that first. So how do I remove that? Well, I do the opposite, which is plus 12. But remember, do the same on both sides. That needs to be done on both sides. So now what we're going to do is the next line of the equation, which would look something like this. And remember, this minus 12 and plus 12, they cancel out now, because that was the aim. We were trying to remove the minus 12. So if we were trying to remove the minus 12, then we add 12. So that minus 12 will not be there anymore. And all we have is 5x, and then equals, and remember, it's 18 plus 12. So that makes a 30. So at this point, what we've got is the second line of the equation, 5x equals 30, but actually that's not finished yet, because remember, ask yourself the question, what are we trying to do? We're trying to say x equals, but at the moment we haven't got x equals, we've got 5x equals. So how do we do that? Well, this 5 is actually multiplying or timesing with the x. So how do we remove times by 5? Well, hopefully you guessed, we divide by 5. So again, we're going to do that on both sides. And just to reiterate this backwards BIDMAS, we'd done the subtraction, we didn't have addition, and then we got to multiplication, which was what the 5 times was. And in fact, it's quite trivial anyway, because the 5 was the only thing that was left, so that that's the last thing that we have to remove. So we didn't really need to do that, but it's just to prove that backwards BIDMAS and the multiplication comes next. But anyway, the 5 times x, we divide by 5 on both sides, and then what we have left on the next line of the equation will be an x here, because the 5 is gone. Remember, ask yourself what we're trying to do. Get x on its own. What have we removed? The 5. Okay, so there's just an x left. On the right, we've got 30 divided by 5. Hopefully you know your times tables. That's x equals 6. So the answer, or the solution, is x equals 6 for this particular problem. Okay, one last example for two-step equations, which is 3x plus 9 equals 27. Well, how do we solve this? Exactly the same way again. In fact, I'm not going to use the balance scales this time. We're going to try and do this a little bit more mathematically and not rely on the use of graphics. However, you can think of it as we go through, and I'll try and explain that as I do it. So 3x plus 9 equals 27. Well, what are we trying to do? We're trying to get x on its own. So what I'm going to do is underline the bits that I need to remove, which is this 3 and the 9, or the plus 9 rather. What do I move first, the 3 or the 9? Well, we've got this BIDMAS over here. Subtraction, we haven't got any. Addition, well, we've got a plus 9, so that kind of tells us that we need to move that first. Okay, so how are we going to do that? By taking away 9, but we do that on both sides. So then on the next line, what we have is just 3x, because that plus 9 is gone. But 27 take away 9 is 18. So that's what we have, 3x equals 18. I'll change the colour because it's not as clear as I hoped. 3x equals 18. Okay, the next step is 3 times by x, so we want to get rid of that 3, and again it comes to multiplication. So this is very similar to the last one. So 3 means we need to divide because it's actually timesing at the moment, so we do the opposite. Remember, it's always opposite. If you don't do the opposite, then you'll be making errors. So divide by 3, what are we going to be left with? That 3's gone, so x is on the left, and 18 divided by 3, times tables again, makes x equals 6. And again, the importance of this is that we do the same on both sides all the time, every step. And as you can see here, this is step 1, which we took away the 9, and then step 2 is dividing by 3. So that's why we call it a two-step equation, because we have 2 steps in order to solve. Okay, so that's enough for 1 and 2 step equations. I'll remove that for now, and we're going to look at some trial and improvement. And to do that, we'll look at an example of 5x take away 3 equals 27. Okay, so how do we do this? By trial and improvement. This is a completely different method, although what we could do is look at exactly the same method we've done before. It's 2-step if we wanted to do that, because we've got a 5 and a 3 there. But we're going to kind of ignore that for now, the 2-step way, and just look at how to solve something using trial and improvement methods. And the way to do it is looking at a grid. In fact, before we do a grid, we'll look at the idea of trial and improvement. What does trial and improvement mean? It's a very misguided concept, where people sort of think that you need to guess, and to a certain extent we do take an initial guess, but that's the trial part, and then we improve, and the improvement thing is very important. We need to improve. We can't just keep guessing what the answer is, because let's say I'm going to take initially a first guess and say I think it might be 2. And by saying that, I can check it out, because I can say, well, I think that x is 2. So this is where I'm going to start making a table. So what is 5x? Because we've got this 5x bit here. What is 5x? Well, that means 5 times 2, because x is 2 at the moment. So 5 times 2 equals 10. Okay, so that's the second column. That's a bit bent. The second column. And then I need to take away 3 from that. So 10 take away 3 makes 7. Okay. And what the answer we were looking for, we've done 5x take away 3, 5 times 2 take away 3. We were looking for that to be 27. But my guess of 2 only gave us a 7. So actually, I can say that I'm too low. In fact, I'm quite a bit too low. So the next step is to improve and say, well, I know that 2 was too low, so I'm going to go up to, say, 8 and see how that works. So again, I'm going to do 5 times by 8, 5 times x. X is 8 in this case, because we're improving the guess or the estimate to an 8. So 5 times 8 is 40. In fact, I'll write this down. 5 times 8 is 40. And then we're taking away 3, so that makes 37. So we were after 27. Remember, this is the key answer that we're looking for. So 37 is too high. So the next step is to then go a bit lower, improve again, and say, well, I know it's not 2, that's too low. I know it's not 8, it's too high. So let's go somewhere in the middle. And I'm going to choose 6. So 5, so then just do the same process again. 5 times by x, 5 times 6 is 30. And then take away 3 from 30 makes 27. And if we see back here, it's actually the correct answer. So I know that x equals 6. And that's correct. So that's the way we do trial and improvement. And this can work for slightly harder equations as well, if you really want to continue to do it like that. However, usually the 1 and 2 step equations using the balance technique that we done right at the start of this video is a bit better. So very quickly, one last trial and improvement effort. So x squared minus x equals 132. So this is very much harder. It's not exactly a 1 or 2 step equation, because we've got these x squareds and another x and things like that. So it can't actually be done the same way that we've done the last ones. However, we can do it using trial and improvement. So what I'm going to do is draw grid lines just here. So my first column is my estimate at the value of x, and what I can do is go in and have a reasonable guess, is it? Because there's 100, the answer's 100. I'm going to be, so what I'll do is try something along the line, I suppose.
Okay, so the next step would be to say, well, what is
X squared? In other words, here we go.
There is an x squared here, the column for x squared. 15 squared, so 15 times by 15. You can use various techniques for this. Those of you that might know your times tables will know that it's 225. You can check it on your calculators if you want. Okay, so 225, and then we've got to take away x. So the next part of the equation says take away x. So take away x. So we're taking away 15 now. So 225, take away 15. So that makes 210. And remember, the answer was 132. So this is actually too high. And this column here, you can just sort of keep it as a question mark, because to sort of say, how are we doing? Okay, so that was too high, so we need to refine or improve our guess, our estimate, to something lower than 15. So how about we choose 10 and see how that goes. 10 squared, x squared, is, x is 10, so 10 times 10 is 100. Hopefully you should know that. And then we're taking away x, so take away 10. 100 take away 10. 90. Remember, the answer is 132. 90 is probably a bit low. So we know it's somewhere between
15 and 10, because 15 was too high, 10 was too low, so it's going to be somewhere in between. So let's choose 12 and see how that goes. X squared, 12 times 12 is 144. Take away x, so take away this 12. So 144 take away 12 is actually 132. And if you look at the answer, we can say that this is actually correct and put a nice big tick there and say that x equals 132. There we go, that's the trial and improvement method. The big point to take away from today, trial and improvement is quite useful. It does take a long time though. The equations that we started off with, the 1 and 2 step equations, are fundamental to remember that if you do something on one side you must do it on the other. So please remember that. Revisit the video, try some questions yourself, and give it a go. Thanks very much. Visit the video, try some questions yourself, and give it a go. Thanks very much. Laura, so here's a single bracket expansion. Are you happy to give that a go?
Yeah, would it be 6x plus 5?
No, actually, it's not quite that. Not quite right. Do you want to give it another go?
Oh, was it 3 times 5 as well?
Yeah, 3 times 5 as well.
So it'd be 6x plus 15.
Yeah, perfect. Well done.